Okay, so here's the video for the practice, page what? 23, 24, and we got, who do we got in here? We got Alexia and Malcolm and Charlie. All right, so let's start here at the top. Evaluate the expression when x equals -3 and y equals 4.1. So we know we have to substitute. So we put -3 where the x is, and then we put 4.1. So I'm going to use those parentheses to show multiplication. All right. So we do multiplication first. What's 2 times 4.1?
8.2.
8.2. Okay, I have a positive and negative, so what's my sign?
Positive.
Okay, and then I subtract. So 8.2 minus 3 would be 8 minus 3 is 5, and you got 0.2. Good. Okay, so the next one. So I start with y this time, so I have 4.1 minus, so I'm going to have 4 times that -3. Okay, so I'm going to do the same change switch right off the bat. All right, so we know we do multiplying. So negative times a negative, positive, so I get 12. And then 4.1 plus 12 is
16.1.
Easy stuff. Okay, 5.2 times x is -3 minus y, which is 4.1. So I'm going to do my same change switch. Okay, positive times negative,
It's a negative.
negative. So I got 52 times 3. We know there'll be a decimal. So 50 times 3 is
15.6.
150. I'm showing you how we do it in your head. So 50 times 3 would be 150. The 2 times 3 would be 6. What's 150 and 6?
156.
And we know that there's one decimal place. Okay? Right. Negative plus a negative is a negative, and then you add. So I got 15 and 4 is 19. 0.6 and 0.1 is 0.7. All right, x and y. So we got, we're going to start doing the evens now. So I got -3 times 4.1 minus 10.1. So negative times a positive? Negative. 3 times 4.1. Now, again, you want to do it in your head. 3 times 4 is 12. 3 times the 0.1 is 0.3. You don't have to write that out. Okay, let's do same change switch. Since we've been concentrating, negative plus a negative. Negative, and then 12.3 plus 10.1, or negative
0.2.
4. Okay, let's go to 24. So here we have what in it? What's that?
Absolute value.
Absolute value. Absolute value is always,
Positive.
so I have 3 times -3 minus, and then 4.1 inside. Okay, we always do absolute value first, but there's no computation here, so it's like grouping symbols. So I have to do that. All right, so what's 3 times -3?
-9.
And the absolute value of 4.1?
4.1.
Okay, so our same change switch. Okay, so I got negative, and a negative is a,
Negative.
and 9 plus 4,
-13.1.
and then I have my point. All right, we're actually going to do 25. The lowest point in North America is Death Valley, about 400 some miles from here. Its elevation is at -86 meters. So if here is Death Valley, okay, so from here to here is -86 meters, so about a football field. What is the elevation in feet? Well, anytime I do a conversion, it's basically a proportion. So here's my original conversion number. 1 meter equals 3.281 feet. So since this is a proportion, remember I got to have my labels correct. So what's going to be on top?
Meters.
What's going to be on bottom?
Feet.
Well, which other number do I know? Meters or feet?
Meters.
No, I know meters. So that's -86. So that means I'm trying to find that x. So now we just multiply. Okay, remember, we multiply the diagonal where we know both numbers and divide by the third one, which is a 1, so it's easy. So, go ahead and use our calculator. So I have 3.281, and then I have 86 of those, because every meter is one of those. And then we'll do the negative afterwards. Okay? So that's 282.166. But it's negative, because remember, it's going down. And then what's my label?
Feet.
Feet. Okay, lava flow, a kind of lava, all right? was that block lava is moving away from the base of a volcano at the rate of 1.5 meters per day, so about as far as you can step. If the lava continues to flow at this rate, so it's the same all the time, that's what rate means. How far away has the lava flowed from the base of the mountain in 30 days? So here's, and it's flowing down here, and it's going 1.5 meters every day. So technically it's like this, and I have how many of these? 30. So instead of doing 1.5 for 30 days, what operation do I use to make it faster? Multiplication. I have 30 of those 1.5s. So that's going to be 0, 15, that's 4, 1 decimal place in my problem. So 45, and what's my label?
Meters.
How far away has the lava flowed? So it's
45 meters.
45 meters, which obviously makes sense. Okay? Number 27, after recent snowfall, the snow on the ground, okay, is melting at a rate of basically 1/100 of an inch per minute. So here's all this snow on the ground. Okay, and it's melting because of the heat. There are 4 inches of snow. All right? If the snow continues to melt at this rate, same all the time, how much snow will be on the ground in 6 hours? So it melts this much every minute. I have 6 hours for it to melt. So what operation am I going to use? It melts this much every minute. Okay, so here's my snow. So here it melts this much, then it melts this much again, then it melts this much again, that little bit of an inch. And it does this every minute. And we want to know how far it melts in 6 hours. So what is happening over and over and over again? Okay, well, if I subtract the same thing over and over again, what could I do?
Just divide it.
No. When I do something over and over and over again, what operation does that tell you? If I say you worked for 40 hours and you got $8 an hour, are you going to go 8 plus 8 plus 8 plus 8? No, you're going to multiply. So I have 6 hours of this happening. But now, I have minutes here and hours here. So I have to change this to minutes. So, what's the conversion between minutes and hours? 60 minutes is 1 hour. So just like this problem up here, I'm converting. So I have minutes on the top, hours on the bottom, and I know that there's 6 hours, so I'm trying to find the minutes. So I just multiply here. 6 times 60 is 360 divided by 1 is 360 minutes. And I know that it's going to melt 0.01 every time. So I simply multiply. So it's 0, 6, 3. I have 2 decimal places. So that's 3.6 what? What's the label? No, because, no. How much snow will be on the ground?
3.6 inches.
So this label is inches, but how much snow will be on the ground? 3.6?
Oh, 0.4 inches.
0.4, because I had to subtract. 4 inches total minus 3.6 leaves me 0.4 inches on the ground. How much snow is melted? Obviously back to the 3.6. Okay? Well, we're going to go ahead and do this one tomorrow, so let's go to the next page because we're at 9 minutes. Okay, distributive property, that's easy. You've done this over and over. 5 times x, 5 times 11, right? 3 times x, 3 times 12. Negative 4 times x, negative 4 times 8. Okay, so 9 times 2x, 9 times 1, what would that be?
18x plus 9.
Okay, let's go to here. So now we go backwards, so I still go over to here first. So 5 times 4x, 5 times 3, what would that be?
20x plus 15.
Okay. Alright, now we got some x's going, so it's a little bit different. So remember, numbers with numbers, letters with letters. So x times 4x. What would this number in front be?
1.
What's 1 times 4?
4.
What's x times x?
2x.
No, come on. What's another way to write that when I multiply a number times itself? What do I
X
use? X squared. What's x times 1?
X.
Just x. Very good. Okay, so now we continue to use that idea over here. So what's 2 times the 1 in front? And what's x times x?
X squared.
Good. Okay, what's 2x minus 1? What's 2x times 1?
2x.
Okay. Well, let me get the phone on our video.
I like turtles. Princess time.
There you go. Okay, so here we go. So we're going to identify the terms. One class, we know that a term is separated by addition. So, I'm going to use the highlighter. So here I have a term, here I have a term, here I have a term, there I have a term. So how many terms are there?
4.
4. Okay, which ones are like terms?
Like terms. -8 and 5.
Negative 8 and the 5 and 2x and 11x. Okay, and of course that's what allows us to combine them if we want. Okay, what are the coefficients now with these?
2 and 11.
Okay, 2 and 11 are coefficients. We use coefficients when we add, subtract, multiply, and divide variables. Okay, let's go to 11. So let's do our same chain switch. Okay, how many terms are there?
There are 4 terms.
Okay, 4x squared, 1, negative 3x squared, so that's why we put that same chain switch, and then 5. Okay, what are my like terms?
1 and 5.
Okay, 1 is 5.
4x squared and 3x.
Okay, so this is, what kind of term is this?
Squared.
What do we call this? What kind of term?
Variable term.
But what specifically, what kind of variable term?
X term.
Nope, because they're not x's.
Oh.
They're x squareds. I can't add, if this were my problem, 4x squared plus x, I couldn't add those. That's not 5x squared or 5x. This is all you could do. This is different than that. Okay, they kind of look alike, but this is like having the red delicious apples, and this is like the granny apples. If I go to the produce section, they're in different bins, aren't they? Okay, even though they're kind of the same. Okay, number 12, let's do our same chain switch. Okay, how many terms do I have there?
4.
Okay, what are they?
7y squared.
Okay.
3y squared. And then -6 and -15.
No, let's see, she got that part right. Okay. So if you can identify that, you can do the rest. Okay, let's skip. All right, simplify the expression. So now we can go ahead and combine like terms. What am I going to combine here?
You're going to combine the 6 and 3.
All right. Now, in algebra, we put variables in front of number terms. So we should put the 10x first. And then 6 plus 3 is?
9.
9. Okay, do your distributive property. Remember when we solved the equations, you had to do that first? Because this isn't 3x. It's actually 2 of those. So I have to do my distributive property first, then I can combine. So what am I going to combine here, Charlie? Which is 10x, and then I have my 2. Okay, number 16. All right, so I have 6 times 5 minus 6 times x. Okay, let's do our same chain switch again. What am I going to combine here, Alexia?
12x and -6x.
Which is?
6x.
And then I have my plus 30. Good. Okay, let's now do evens. So I'm going to have 8x plus, what's the distributive property?
Well, 6x plus -1, or -3.
Minus. Or, and now let's do our same chain switch. Let's do our distributive property first. Now when we combine, obviously I have 14x and that -3. Okay, 20. Now here's the screwball one. When I do the distributive property here, this minus on the outside means I have to distribute everything. So technically this is like a 1. So now if I do same chain switch, what's in front of the parentheses? No, a -1. So now when I do this, that's 11x plus a -1x plus -7. Now, what your algebra teacher probably will have you do eventually is just recognize that this minus also stands for negative, which means opposite. So I'm simply going to take the opposite of everything inside. So this was positive x,
No, it's negative.
now it's negative x. This was a positive 7, okay, now it's a negative 7. So it's a teeny bit of a shortcut. Okay, now when I combine, I get 10x plus negative 7. Okay, so let's go ahead and do, on 22 is kind of the same deal. So now there is a 3 in front. So again, I'm going to do my same chain switch. So it's not a 3, it's a,
Negative.
and now I can go ahead and do my distributive property. So what do I get?
7x plus negative 12 minus.
No, we want to keep that minus yet.
Minus negative 6.
No. Oh, yeah, you're right. That's a negative.
Negative 6x.
Negative 6x. Now let's do our same chain switch, which obviously now makes that a positive 6x. Does that make sense?
Yes.
Yes. So
7x and 6x
13x.
plus negative 12. That's it. And what we're doing is getting prepared to obviously solve equations here in a little bit. So it's just like that one unit that we had. Okay, all good? Say goodbye.
Hola.
Hi. What?